Great. So I'm Glenn Schulz. I'm the Managing Director of the FDT Group. Just a little bit of background about FDT. We're an international nonprofit organization. So we exist in the industry to really support the FDT standard that we're going to talk to you about today. So we're the original authors of the standard. Several companies got together many years ago and started this process, and it came into being into this FDT organization. And now our job is we maintain the standard, we update the standard, we add features and so on, and then we promote the standard around the world, both with end users and these kinds of events, as well as with the manufacturers that are in the industry. So the FDT Group is fully supported by membership of companies, individuals, universities, consultants, and end users who have an interest in seeing the FDT standard continue to advance. And so that sets our budget for the FDT organization, and we operate within that budget that is a non-profit entity. So Katrine is our office manager of the FDT Group. She's out of Belgium. I'm out of Germany, as they mentioned, but you might be able to tell from my accent, it's an American accent, not a German accent. But I've lived in Germany for 3 years now. So what I'll do today is give you a little overview about the technology itself, and probably the key thing is just to take away some of the terms that you're going to hear Juan speak about, and then you'll see live in the demos when you go into the demo areas. So just a little bit about a little bit about how we got to this spot, and I think it's anybody that's in this industry sees this trend actually getting more and more profound, is that nowadays most projects have multiple vendor scopes in it when you're working on an automation project. Years ago it used to be you'd go to one of the big vendors and they try to deliver as much of the scope as they possibly could, and you kind of dealt with that because it integrated so well and that's the way things work together. But time has moved on, and that's what our standard does, is addresses the fact that you'll often have a dozen or more device suppliers in a given automation project. You can have countless number of device types and even thousands of I/O points all delivered by different vendors in that architecture. So that's the reality of automation projects today. Probably the most profound impact of that is just the number of vendors that you have to deal with on a typical automation project. You've got all the different types of devices. Most vendors tend to specialize in certain classes of devices, and so you're dealing with a wide variety of people supplying plant equipment into that environment. And then if that isn't complicated enough, even though most companies will try to dictate a few, maybe one primary network standard that you'd like to work with from an instrumentation perspective, the reality is that other stuff creeps in. It either comes along because some other part of the plant needed a different kind of network because of the kind of controls they were doing. A typical example would be if there's any kind of high-speed motion control activity going on, that's not going to run on the same kind of network that a temperature transmitter is going to run on. It's going to be a completely different kind of network. Or it might be that you've got a legacy plant and there's stuff in there from days gone by that you just can't convert. You got to deal with it. It's on a different network than the one you prefer to work with. So the reality is you get this often multi-protocol type environment in your plant that you just simply have to deal with in the control system. So the result of that is, if left to its own device, every vendor would send you some little tool to help configure, manage, optimize their device. It'd probably be a very nice tool, but unfortunately, you get a stack of CDs or DVDs from all these vendors and then try to maintain all of those tools and so on and so forth. This is where the FDT standard enters into the game, is so that we can avoid this kind of scenario, which many of us have had to deal with in the past. So the FDT standard really is a platform for bringing all phases of the automation project lifecycle into one platform and be able to exercise all of it. So sometimes people mistakenly believe the FDT standard is yet another network standard. It's not. We simply deal with all the network standards that are out there. We don't create any new networks. New networks are being created all the time by other standards organizations, and we work with them to make sure it's compatible with the FDT standard. So we're not specifying any kind of network. In fact, You could literally say we're network agnostic. We don't care what networks you work with. We make sure our standard works with all of them. So we kind of sit on top of that whole thing. So who benefits from all this? There's really different classes that benefit from the FDT standard. I think pretty clearly the device manufacturers get a huge benefit out of this because they want to play on a variety of platforms because they want to specialize in their instrumentation or their device type within the automation architecture. And they just want that to be able to run on any higher level system that you as the end user wanted to run on. So whether that would be a DCS system, a PLC system, an asset management system, a maintenance system, whatever it is, you want to have that higher level system of your choice, and these devices should plug in. So these manufacturers of all the peripheral components get the benefit from the standard that by using the FDT standard, they automatically plug in to all those other applications. Kind of in the middle of this thing then is all the host suppliers, all the higher level systems that actually do the automation in the application. So that could be a DCS system, it could be PLC-based architectures, it could be a variety of other just programs like asset management, maintenance, those kinds of things, configuration tools, troubleshooting tools, and so on. So those guys benefit because they also now don't have to worry about all the different device suppliers that are out there and how to work with them. The standard handles that for them. So they just need to put one standard chunk of code in their application and they can work with all of these different devices. But probably more germane to today's discussion is the benefits for the end user. As the end user, you now get to choose best-in-class devices. You're no longer locked into, well, I'm buying the DCS from this company or the PLC from this company, so I've got to use their devices or devices that they approve. The standard takes care of that. You can now go and pick best-in-class devices, best-in-class PLCs, best-in-class DCSs, and bring them all together seamlessly in a single application. And that's what the FDT standard is all about. So from our perspective, when we started this process, we really focused this on the end user. We could see the pains that got delivered up into the vendor community for automation, but the right place to start the focus was the end user. So we've always been centered on giving the end user the freedom of choice. We always use the term best in class. You as the end user can now go out and shop for a particular control application, a particular process, or a particular kind of measurement you have to do. You can find the absolute best company out there for that application and be comfortable you can integrate it into your higher level system because of the FDT standard. We also committed to the industry that when we started our FDT standard that we would always be backwards compatible. And that's a tough order to fill, but we just released an updated version of our standard this summer. It's called FDT 2, and that released version is backwards compatible. So if you already have an FDT-based system running in your plant, and now a vendor comes along and says, oh, we've got a new DCS or new PLC that's FDT 2, you don't have to throw away everything that you've already invested and configured. It automatically works with FDT 2. So that whole architecture will just move forward with the new standard. Key to the whole concept of how it was engineered is that you get plant-wide access to all of your data. So all the intelligent devices that have been out there for a long time on networks, you can finally now, wherever you are in that architecture, get direct access to all that intelligence. And I'll show you how that works in just a minute. And then this issue of being able to use it over the whole life cycle. You can start using the FDT standard before you have a single instrument in your possession. If you're doing a process automation type application, or if you're doing a factory automation type application before the PLC even arrives, you can start configuring devices, setting up your asset hierarchy, getting it all set to go. And then as the networks and instruments become available and the I/O becomes available, you can bulk configure that through the FDT standard. So it's got some pretty powerful features. And then that carries on throughout the whole life cycle. If you've got a problem with an asset, wherever you've got an FDT application, you can query that asset to see what's going on. So let's see how this all works. So from the vendor's perspective, they view this and say, hey, this is great because now I just write one device driver and it's going to work on whatever system this device gets integrated into. So to them, that's a huge savings and time to market. In the end, it's probably a good savings for you as a customer that they don't have to have all these engineers writing all these custom interfaces to all the different systems that are out there. It's an internationally recognized standard. We're an IEC standard. We're also on many of the regional standard bodies, so like ISA and ANSI in the US and GB in China and so on, but the big one, of course, is the IEC standard. It's common across all the platforms. They don't have to worry about whose platform, whether it's a legacy platform or current platform. The standard handles all those issues for them. So the companies that support it are now over 90 companies, organizations that support the standard. These are the groups that essentially pay the membership dues in the FDT organization to make sure that the standard continues to move forward throughout the world. And I think when you look at that chart, you see the who's who in automation. There's hardly a vendor missing in there, even though we do continue to add companies. So if you see one of your favorite vendors missing, let me know afterwards and I'll make sure we put a bug in there here. So from our perspective, what we're trying to do is make the FDT standard a seamless integration platform that works across all network architectures and with all device vendors and with all higher level vendors. We've been doing this now for over 15 years in various forms of the standard, and we think we've reached many of those goals. And as Juan will point out through a few application stories, it's a great working standard today. This is a little bit of our timeline. I won't go through this other than to just point out, you can see we really can trace back our start of this process to about 1998, when companies started getting together and saying, hey, this is a real problem to deal with all these systems and how to interface them. And then a major milestone for us was 3 years ago in 2009. We achieved the IEC standardization. We have the kind of neat benefit or the neat characteristic that we were voted in unanimously by all the world body organizations that vote on standards, which is a pretty rare treat. Normally one country or somebody will vote against it because they don't like the way some clause is written in it or something. We had a completely unanimous vote for the FDT standard. So it's now IEC 62453 for the last 3 years. And we continue to move forward. As I mentioned, we just released an updated version of the standard with a lot of new features that end users and vendors were requesting in its capabilities. So let's get on to some of the terminology so that as you guys hear the other issues and things today, it'll all sort of all come together. So, you can look at this sort of in the context of the smartphone market as to what we're trying to deal with. Today in smartphones, it's no longer just a platform for smartphones. It's now a serious question of which platform are you going to buy for your smartphone? Not only which brand, but what platform does it run? So is it Android? Is it Apple? Is it Microsoft? And there's a few other variations out there too that the press doesn't play on much. Well, so you got all these interesting platforms out there, and all of them have their advantages and disadvantages. I just switched to a S3 coming off of an iPhone, and I'm still making the comparisons between those two. But what happens, of course, is you got your favorite apps, or you find some app that is really what you wanted on your smartphone, or maybe it doesn't work on your smartphone because it's the wrong platform. You've got Apple, you find exactly what you want, but it's only available on an Android platform. So the problem is very similar to what existed in the automation industry, is that there weren't a set of standards out there to bring these things all together. So the concept is, wouldn't it be nice if there was just one app market, and no matter what platform you had, Apple, Android, whoever, you could download the app, and it would automatically play on your handheld platform. That's essentially what we're doing with the FDT standard, where seemingly they should never be able to operate together. They operate in a seamless fashion. So that's what we do. We create these apps, and in the FDT terminology, we don't call them apps. These drivers that are created by all the device manufacturers are simply called DTMs. And we allow those to play on any type of platform through our standard. Okay, so here's the concepts of FDT. There's really only two major terms that come up in talking about FDT. And then there's a lot of less important terms, at least for early understanding. So the higher level system, the DCS, the PLC, the asset management application, in FDT terminology, we call those the frame. Okay, that's the higher level system. Then all the drivers that plug into that frame from all the device manufacturers, so temperature transducers, radar level gauges, so on and so forth, I/O points, photo eyes, AC drives, DC drives, servos, all those things. Those device manufacturers create drivers that are called DTMs, and those DTMs plug into the frame. So here you've got a picture of a basic frame application, and the frame is this part around the peripheral, and that's how it got its name, because it always looks like the frame that holds the DTMs. And then this section right in here is actually the DTM. You're looking at one DTM in a frame. Now what's interesting is from our perspective, from an FDT perspective, almost all of our standard deals with this orange line that you see right here. And that's how does this DTM talk with the frame and vice versa? How do they exchange information and how do they work together? That's what our standard does. So we don't care whose frame it is over here, nor do we care whose DTM it is over here. As long as they're following our prescribed standard, they'll play together seamlessly. Now a frame, here we're just showing one DTM, but it's important to realize that in almost every application, that frame is going to have hundreds, if not thousands of DTMs loaded into it, one for every device that's out there in the control architecture. Okay, so that's the basics. You got the frame and the DTM. So a little bit more about the frame. Now we've taken the DTM out of the picture. Now you're just looking at a frame application. Remember, this could be a PLC, a DCS, asset management, it could be a calibration tool. Anything like that can be a frame. Anything that needs to talk with end devices. The frame has on this side of it an asset tree. And Juan is going to show you a little bit more details of that asset tree, excuse me, in just a few minutes. But here's how you navigate through all the DTMs that would pop up over here. So there's a representation of your plant in this asset tree, and when you click on it, you get to the DTM that represents that particular control point in your architecture. And there's some standard navigation things up here and some standard status bars that Juan will give you a little bit more insight into. Then the DTM part of it, this is the app. DTM stands for Device Type Manager, but honestly, we hardly ever use the long term anymore. Almost everybody just calls it a DTM, and I think some people don't even know what that stands for anymore. So it's sort of like IBM. You know, people lost track of what it really stood for. So most people just call them a DTM, but this is the graphical interface that represents the device. So here is where the device manufacturer exposes all the intelligence about their particular device. They write this driver. They're the people that knows the device the best. They write the driver, and what you see here is all their work so that you can interact in the best way with that particular device. And again, this can be anything from a simple photo eye type thing all the way up to mass Coriolis flow meters, AC drives, pumping applications. You know, the sky's the limit in terms of complexity of the DTM. But just remember, the DTM is always supplied by the device manufacturer. So as you look today in the demo areas that are set up here, what they're really going to be showing you along with their instruments or devices is you'll always be looking at a DTM representation of their device. So the DTM comes with the device from the device manufacturer. You'll have a lot of chance to see different types of DTMs, different features of the DTMs, and so on. A few common things that are in a DTM is that it's interesting, they're all protocol independent. So this is very nice for the device manufacturers. They create this device driver for a particular device, and they really don't care if that device then is going to be offered on a HART network, on a Foundation Field Bus network, Profibus, Ethernet. You know, you can go through the list of 16 or more different networks. It doesn't matter. This driver is the same for all those networks. And we handle that because there's another DTM that takes care of all the communications for each one of the networks. So this DTM doesn't have to worry about the network itself that it's dealing with. There's some standard navigation bars and menus here that are always in the same place. And Juan will introduce you to the style guide that controls that so that as the end user, you get kind of a common feel to all the DTMs so that the menus don't appear on opposite sides of the screen, or you don't have to look up and down to find where is the menu today. They all appear in the same basic area, and Juan will show you how that works in this discussion. And then, of course, this graphical area, they're free to do whatever they want to do with the graphical area. And I'll show you a few examples of what some manufacturers have done with that kind of capability. So here's some different DTMs, and there's thousands of DTMs on the market, so we can't even begin to represent them all here, but this will just give you a hint as to what some of the manufacturers do with these capabilities. So here's sort of an advanced commissioning type application, and you can see these kinds of things in the demo lab where they're calibrating a radar gauge, and they're actually profiling the kind of tank that it is, and then it walks you through a wizard application. So what in the past would have been a fairly complex configuration of this kind of instrument, once you set up the tank geometries and a few other things that you're dealing with, it pretty much sets the bulk of the parameters for you. You don't have to worry about looking at lists of tens or hundreds or sometimes even thousands of parameters that have usually a lot of interaction, and most of them you don't know what they're really doing. The wizards now pretty much handle that for you through that kind of interface. Another very popular thing with the DTMs is to handle alarm management. You know, many of these devices have information in them that would help you understand that they're starting to reach a failure point or have reached a failure point. And in the past, it was very difficult to get at that information because you usually were the one that had to write all the custom code, or your contractor had to write custom code for every device to go get that information. And so it was a lot of manual flipping, and then as soon as you added one new device to the architecture, it was no longer included in the alarming. Now many of the DTMs have these features built right into them. That's what you're seeing a few snapshots here. It helps you with that kind of work. Similarly, diagnostics, and you'll see some great demonstrations of this particular DTM today, where it's actually monitoring the health of the network. So not just the devices that are on the network, but now you can sit there and monitor the health of the network, which so often is the problem. You know, in real world environments, things happen like terminating resistors get knocked off of racks, cables get driven over or clogged into by forklifts. You know, all those kind of things are very real world events. And now there's DTMs that actually watch that network performance for you, let you know what's going on so you can diagnose exactly what the issue is and get back to operation. In the past, you'd often lose part of the network segment and immediately assume it's something with the devices and start running out there with field instruments to go look at the devices. Here you can sit comfortably in the control room and say, let's just take a minute and look at the network to make sure the network itself is healthy, and then I'll worry about the end devices. So something that used to be extraordinarily complex to manage is now a few simple clicks with DTMs. A few more screenshots there where it's showing you the health of the different networks and then actual oscilloscope type traces of what's going on in the network. Also, diagnostics and general maintenance is becoming real easy with the DTMs. One of the most complex functions in most facilities to do from a preventive maintenance standpoint is partial stroke test. In the past, it was so complex that companies built a whole environment around tools so that you could do PSTs within the DCS or PLC application that you're doing, because it's a critical function and it's hard to execute properly. Here now you're seeing partial stroke tests being handled completely by the DTM itself. So it's all integrated directly by the valve controller or valve manufacturer to do the PSTs in the driver that comes with the valve. So it's no longer separate apps, it's all integrated into the same platform. Then on the communication side of things, there's DTMs that control communications. Our job is to make sure that every network that's on the market is compatible with the standard. The really neat thing about the engineers that conceived the standard, they realized this was going to be an ongoing battle for the life of the standard, that there'd always be another network coming on the market, or somebody will always be making changes to their network standards. So they didn't want us to have to re-release the FDT standard just because there was another network to add to it, or because somebody added wireless to their previously wired-only network, and then we'd have to release our full standard. So the architecture of the standard was built such that we can add a network at any time just by releasing what's called an annex that just deals with that particular network. And then all the applications that are out there can take immediate advantage of this new network. So in the industry then, the people that make all the gateway type cards, conversion cards from one protocol to another, have a DTM for their card that just adds to the architecture, and then that's all handled seamlessly for you through the FDT standard. So you can have as many networks as you want simultaneously, and you can peer through all those networks to communicate to any device anywhere in the architecture. So this is a real quick example of this. Here we can do the standard point-to-point things. Here you've got just a simple protocol converter. You can plug directly into a device with the PLC. So no network involved, but a very real-world kind of thing. When you're doing it on a bench, because a tech needs to just verify that an instrument's working before they walk it out somewhere, or it was a problem instrument, they're trying to troubleshoot it now on the bench. You know, you can do these kind of things anywhere that you've got a PC. But probably the more powerful thing is to be able to do it anywhere on the network as well. So with the FDT standard, you can have layers of network like this, and without any awareness of the individual networks, we can actually drive packets of data from, say, this Ethernet network through other multiple networks down to a lower level device network like HART. So now I can be anywhere on this architecture with this FDT frame application, and I can talk to this HART device. And I don't care about all the networks in between. It'll be completely seamless. You don't have to deal with it at all. Once you've told the frame application this is your topology, it knows how to go talk to this device without any additional interaction on your part. So we call that stacking, nesting, peering through the networks. Any number of networks that can carry those types of communications, we can handle it all the way through the stack, and it's completely transparent to the other networks. This allows you to sit up in a control room and interrogate anywhere in the architecture, network health, device health, those kinds of things automatically without having to walk around the plant and try to guess where the issue really is. So availability of these things, there's dozens of frames applications on the market. We've kind of lost track of how many there are, but there's at least 15 or 20 major frame applications on the market. There's thousands of DTMs available on the market. We now have registered DTMs for over 5,000 devices. Many times a DTM will handle a whole family of devices, but there's more than 5,000 certified devices. We maintain a certification facilities around the world. They're independent contractors. We audit them, so that if device manufacturers want to have their DTMs certified that they meet the standard, they can send it to this independent test lab. They beat it up according to our standards, and if they say yes and pass all the tests, then we issue a certification for them that their DTM meets the standard. It's not a requirement, but many people like to see that on the DTMs that they're dealing with, and then they can use this logo where it says they've got a certified DTM. So if you're just looking for DTMs and wondering about the scope of DTMs, you can visit our website, fdtgroup.org, and we've got a catalog up there of all the certified DTMs. There's many more available than what's in our catalog, but these are the certified ones. So you can get up there and just have a look. You can sort by instrument type, by manufacturer, whatever you want to do. And you'll get an idea of what's available. The FDT standard works equally well on brownfields where you've got a large existing facility, you may be doing a new process or a new line and you just want to put FDT in that area and see how it works. That works very well. You can also do, obviously, greenfield facilities, and Juan will walk through several examples of this where it's been done both ways. One nice thing about the FDT standard is you may have an existing, say, DCS system in place, and you'd like to just get started doing some better asset management using FDT. You can put an asset management application on top of your DCS without disturbing your DCS at all, just as long as you have the right communication gateways in the architecture. And you can start immediately doing asset management type activities with the DTMs when the DCS continues to do its thing. So it's a nice architecture to be able to mess around with. So just in conclusion, we think we've done a great job of meeting these end user requirements. Obviously, in the end, you're the judge. Our role to you in the industry is that if you get into FDT and you see something that wasn't there that you hoped it would be, or something that could be improved, that's what we're here to do, is listen to your input and make sure that that gets driven into the standard. When we released the new FDT 2 standard, we included, I think it was 40 new feature requests and only had to leave 3 behind on this release that were requested, just because time ran out. We just couldn't get them all done. So those 3 will get picked up in the next release. So we're always out there listening. You're an important part of that process for us. You don't have to be a member of the FDT group to give us your input, so always feel free to let us know what you think once you get into it.